So now we have a perfect spherical map that we can use along with an HDRI if you wanted to, or setting it up as another plate for compositing. And we've got some nice little steps in between the different cloud layers. You can really see the distance very well. Turns out to be a pretty good Z-depth. I'm going to take a look and just save this out as an HDRI, and we can take a look and see if maybe we need to tone down the light. But other than that, all we need to do is invert it. So I'll go ahead and save this picture, and I'm going to call it ZDepth underscore clouds underscore spherical, and set this to an EXR 32-bit image. So let's go ahead and open that up within Photoshop. Now I also want to note that because of the distortion from a spherical render, you will see a very harsh and quick contrast change between the lighting. You'll definitely notice a lot brighter areas on the top, but that will really be, if you were to look at this within a normal perspective of camera, normal focal length, we would really only see, if we were looking straight ahead, just a very small area of this, and the rest of it's going to be distorted and really shrunk down. So if you find you need a higher resolution image, for the most part, you really only need to render the area by the horizon, and then you can composite and mix the two images together. You could set up a render area just to render out the area by the horizon, because the rest of it is going to be distorted so much that increasing the resolution isn't going to make that much of a change, just increase render time. So once again, if we take a look at the Z, we see nothing. If we take a look at the alpha, we see nothing, because the ground isn't rendering, and we don't have any cloud masks or G-buffer on. So let's go ahead and just take a look at this image in Photoshop. So one thing you will notice is that that black background is not there. For the most part, the entire sky was covered, but if you need to, the way we had it set up is you can just adjust the levels, maybe bringing in the black, because we can see there's only a very small separation between the blackest part and beyond that. But for the most part, that white area is a little peaked. We can definitely see that within the histogram. And if we tone down the white just to see what would happen, there is definition in there. And like I was saying, most of that is going to be distorted, so that won't matter too much. But overall, that should work as a pretty good Z-depth. If not, reduce the power of that light just to bring it down, or adjust that ambient amount. So all we need to do is invert our image, and since we were working with the 32-bit image, the invert option is not available. So if we take a look, it is what would be grayed out, but my color scheme is a little bit different. And since we're not lighting a scene with this, really working with 16-bit won't be a big deal. So we'll convert that, and might as well merge it. If we want to adjust the gamma, we can. Exposure, we could tone it down a little, but I think we're just going to lose too much definition changing the exposure. In the case of switching it over and modifying the bit depth, I really don't recommend changing exposure. Gamma should be fine. We'll just leave it at 1 and click OK. And now we can invert. And we have the Z-depth that would match the typical view system, which is black closest to the camera and white farthest away. So this way we can modify atmospheric effects and modify the atmosphere. And it looks like my camera might have been off a little bit, but that could just be the distortion Setting it to 90 is usually enough to make sure that the horizon isn't stretching, and that's more than likely just the cloud layer effect. So the white areas of the scene are the atmosphere. Since we have such a dense cloud layer filling all that in, we're not really seeing bright white patches. There's no real breaks in clouds. If we were to create that, we'd see it a little bit better. Well, I think we've spent enough time on this, although I do want to show one last thing, which is basically just how it works above the clouds. So I'm just going to set that up really quick. Go ahead and close this out. And what I want to do is take the camera and move it above the cloud layers. I'll probably have to remove one of them since it's just flat and we have so much coverage. I am going to turn off the spherical render for this and panoramic. You could just turn off panoramic, which will automatically turn off spherical since it's only available if panoramic is checked on. I'll go ahead and change the aspect ratio, which is now set to the other one. We'll do a Academy standard flat. Just open it up slightly. For the most part, we're not really seeing much. Since no shadows are being cast, we can actually leave the light where it's at, but the only problem is it's not close enough to the camera, and that is going to cause some issues. So first we need to, let's just get rid of some of the layers of the clouds. What we can do is just check them off, or basically close the eye so they're hidden. Take the spotlight, and what I want to do is move it up above the camera, and we can rotate it. I'm going to change the just to 0 to make sure we have just on a nice tight axis, no variation. And holding down Shift, making sure you're using the rotation gizmo, holding down Shift first before you click on one of the axes to rotate so that it snaps in place. If you hit Shift afterwards, it will snap to the offset that you have. So if I was to click first and start to rotate and then hit Shift and start to drag, even though it says the value, it's a little incorrect. So what you need to make sure you do is hold down Shift first, and then you can drag it over. And now that's going to be closest to the camera. And we can take a look with the reduced cloud layers and see that it also works from above. So just about anywhere we go, we just need to make sure that if you're above the cloud layer, that the sun is, or the spotlight is above the camera pointing down. If you're below the cloud layers, the spotlight needs to be under the camera pointing up. So it's pretty straightforward, fairly simple. And it's a really, really useful technique. And like I was saying before, if you need to increase the depth a little, if you want to kind of embellish, maybe to create some extra effects within compositing, you can either change the scattering amount. There's one last thing I want to show you, and that is basically you can turn on the internal shadow option to increase the depth a little more. It looks like maybe in this case it might be too much. You can see a lot of depth in there, and that's because of the quality boost setting. So if you were to use shadows, you would have to increase the quality boost. But if you wanted to kind of show the edges a little bit more, show some of the extra diffusion, that is one way you could do it. But for the most part, ZDepth really doesn't need that extra detail. And I was talking before about creating a mask. To do that, just want to show this really quick. Edit the material, make sure no internal shadows, set the volumetric color to white, and you can do that for the other layer as well, or any other layers you have. making sure that shadow is also turned off. And now what we can do is one thing you could do is just brighten up the scene, making sure that the auto exposure is turned off. That's going to create a little bit of an edge around the cloud, which would be nice for a mask, but you definitely wouldn't want to render with this low quality if you're creating a cloud mask. Go to the Sky Fog and Haze tab, set the quality boost. In this case, I'm going to do -1. I'm also going to take that spotlight and increase the power. Let's go ahead and really crank it up. Let's do 40,000. So that way it's just completely a harsh cutoff around the edges. So you can adjust that little bit of a fall off in the edge anti-aliasing or the edge opacity just by increasing or decreasing the power. In this case, we'd have something very, very harsh, which is similar to the view mask. I think it's difficult to use when it's like that because it creates an edge around the clouds, and having a little bit of an opacity change can sometimes be helpful. So you can also adjust the density, but for the most part, this will create a cloud mask. And you can render this just as you did with the other images. If you're having problems with the depth, basically in the scene, basically the distance of the clouds, where they're not white all the way through because of the size of the scene, as we can see if I move the camera, this won't work very well for a mask because it's too opaque. There's too much transparency in the back because the light isn't large enough. What you could do is increase the spread to 180. That's not really working too well because it is a spotlight. One thing I want to do, turn off the spotlight. So we'll go ahead and right click, and we're going to replace, and we'll keep proportions with a directional light, which in this case will now act as the sunlight, because whenever you have a directional light, it becomes the sunlight. So since our sunlight's turned off, the new directional light is taking its place. So I'm going to go ahead and undo that. Now we just have the spotlight. For the most part, you should be able to just crank up the light intensity a little bit higher. Like I was saying before, adjusting kind of the definition around the clouds, it does become a little more difficult to do that when you have a larger scene. If you really need to, just copy the light and kind of move it over that area, and that'll work pretty well. And that way the fall off amount isn't really adjusted. Another thing too is you could select, we're going to select the spotlight. Up here we can click edit shadows, and that's just going to open the light editor. We can go to the lighting, and right now we have a linear cutoff. If we set this to custom, we can edit the filter, move up the right all the way, which would normally have it drop off, and the cutoff distance will just make a very, very large amount. And that should pretty much take care of it. If you intend to create a ZDepth pass for an animation where you have the camera moving through the clouds, then another setup is going to be required. And there can be a simpler way to set up the scene. And there are also a couple of other render settings you can use to improve speed. So first of all, what we need to do is make this compatible with moving through the cloud layers. And instead of just restricting it to being above or below the clouds. And this technique can also work uh, for the current method, whether you're below or above replacing the spotlight. But the spotlight will typically render faster than what we're going to be switching it to. So the setup is a little bit easier, and all we need to do is basically we can delete this spotlight from the scene, and we're going to add in a point light. And now if we open the graph and edit the object graph for our point light, what we can do is add in input node external dependency and select the main camera position, or whichever camera it is you're using, and then connect the position of the point light, the output node position, to that input of main camera position. So now we don't have to worry about lining up any of the lights to the camera. And all we need to do is increase that power once again. And let's go ahead and do a value of 5,000 and influence spectral clouds. And we have the same kind of a setup. Now when you're moving through the clouds, you may notice some brighter patches, and depending on how far away you need the ZDepth to go, you may need to reduce the overall power of the light in order to get consistency throughout the scene, or restrict how far you'll be able to control the ZDepth. So with that set up already, what we can do is grab the camera and move it into clouds. Right now we're directly inside of a cloud. There's one right overhead. We can see it is showing up correctly. But let's go ahead and find somewhere where we can see a little bit more what's going on in the scene without actually being inside of a cloud layer. And it's just going to be a matter of finding a spot. So the best way is just to move above the clouds, kind of point the camera down, take a look at a render, and see somewhere where you'd be able to easily place the camera. And it looks like we've got a spot down here. And then we can reposition the camera a little. And it looks like I'm still inside of a cloud layer. So really quick, I'm just going to find a spot where we're not inside the clouds. Oh, here we go. I also want to note, and this applies to any time you're rendering spectral clouds, when you're within the volume and the space of the volumetric material, it does take longer to render. When you're outside of the space that it occupies, it always renders faster. But now, just taking a look at this preview render, we can see the cloud showing up. And it is taking a little bit longer because we are inside the cloud. We'll go ahead and modify position a little. And what we can see is a nice cloud coming in front of the camera and some different layers behind. We can change the focal length a little so we can see a little more of the scene. And now we have this almost complete white peaking really close to the camera. And that might be alright if you really need to see the different areas of depth. But if you need more definition directly in front, I would highly suggest that you just kind of tone down the intensity, and what you'll have to do is just lose some of the definition in the back and maybe cut out the scene a little further. It really is going to depend on what you're using the ZDepth for. Another solution to this would be to add in some sort of separation between the clouds, and you could create different plates. One thing we could do is put a plane just behind this set of clouds, and then turn down the exposure so it just goes in between the plane, or sorry, turn down the power of the light so it goes in between the plane and the camera, and then you can adjust and fine-tune the area right up front, and then have a separate pass for the rest of the scene. That would also involve having an overlay, because you wouldn't be able to just remove a portion of the cloud layer easily. It is possible. One thing that can be done is connecting uh, a tooth Gaussian noise as a subtraction of the cloud layer to the position of the camera. This can also be done with a tool I created called Advanced Sphere Zone, or the normal sphere zone, which is part of Snowflake, which takes that tooth Gaussian and modifies the size correctly and allows you to really manipulate any fractal or any function whatsoever by using a sphere as a control for the scale. So that would also work to cut out a cloud layer. Although the material position and coordinate system might be slightly different, so you may have to offset the position. If we take a look at some of the ways to increase the render speed with this technique, if we go to the render options, we're going to turn this to the user settings. We're going to turn off enable subrays, apply materials, super sampling, take the advanced effects quality, we're going to edit, and we're going to turn off the indirect lighting on plants, turn on the custom settings, turn off adaptive sampling. Take our volumetrics, bring it all the way down to faster. Really moving this between faster and better doesn't appear to affect the time of the render, nor the quality in this case. We'll just go ahead and leave that down at 0. Turn off anti-aliasing. One thing that will drastically increase render speed is turning and checking on optimize last render pass. Since we really don't need the multipass or G-buffer for this, because we're creating a separate pass in of itself by making this scene, we don't need to worry about the fact that we no longer have the option to use enable G-buffer, enable multipass, and using the outputs because this is checked on. Because whenever you have this option on, it will not allow you to create the multipass. There are also a few more things you can do within the atmosphere editor. What I want to do is go to the Sky, Fog, and Haze tab and turn down the sliders for everything in the sky, and then also we'll get rid of the fog and turn our scattering up to 1. I'm going to bring down the quality boost to -2. And now if we move over to the light tab, this time what I'm going to do is turn off affecting the sky and clouds, and also apply these settings to only the sunlight. And what we're going to see is a little bit of a change in the overall lighting of what we're seeing in the scene. I'm going to go ahead and increase the scale of this preview so you can see it a little bit better. Make sure we have the fast render quality. So if we take a look at applying the setting to only the sunlight and any of these options, and working with the point light separately and its own independent options, you can see this darker cloud right here and a very light spot in front. I'm going to go ahead and turn back to all lights, and we're going to let that refresh, and what we're going to see is everything brightens up because it's now using that 100% sunlight option. And we can also tell that the depth in the back is showing up a little better. So this is more of a a way to adjust things closer to the camera, we would need to increase the power in order to get that light to show up beyond this area of the scene. But it is just another option and another way to manipulate this type of setup. If you find that you're losing the definition you need towards the back of the scene, increase the power, or like I was saying before, you can kind of create those different plates to separate the clouds. Under the sun, just to make sure, I'm going to get rid of the size of the corona and also the size of the sun. It shouldn't have any impact or really make any changes, but just to be sure. And now we could take a look at rendering this out. Once again, the quality boost setting in the sky, fog, and haze tab will change the shapes of the clouds. And you can also notice that we do have a little bit of a grainier of a render caused by that. And if needed, you can apply a few post-process effects, maybe a blur, but for the most part, you'll really get the sort of information you need, even from a grainy render where you can easily blur that. Most of the effects you really would end up doing will still apply correctly. And if you're working with just a still, let's say these foreground clouds, if we just wanted this section to be a little bit of a better quality, if we needed it better, then we could just do a render area. And what you could do is just drag out the render area in the scene, and then just turn the quality boost up to render just that specific area a little higher quality, and then you can overlay that image on top of the other one. So that's another way to just kind of fine-tune the scene a little. And if you right-click, you get some more options for the render area. If you're not familiar how to use it, you can choose to select the render area if you want to choose a new one. Whether or not you want to use the render area, you can discard it, and then you could also choose render. So I'm just going to discard it, get rid of it. And there's just one last option, and that is to select the point light and select no shadows. Whether or not this will really make an impact, it probably wouldn't, considering nothing really has shadows enabled, but just in case something was in the scene that was interfering, then we could just make sure that that's off. So we can see this nice overall ZDepth created from within the cloud. So once again, whenever you're within the cloud and the volume, it will take a little bit longer to render. Using the method of the point light will also increase compatibility with spherical scenes and panoramic views. And not having to worry about the orientation of the spotlight is helpful. But I have noticed that the spotlights can tend to render a little bit quicker. So if you're not going to be really going through the cloud layers, sometimes it's a little better of an idea just to stick with a spotlight rather than using a point light. But if we go ahead and move outside the cloud and take a look, we're going to notice, of course, a lot quicker of a render than when we're inside of the cloud. Also keeping in mind that some of these cloud shapes I have are fairly complex and have a somewhat overextensive internal function creating the overall shape. So they can take a little bit longer to render sometimes. A lot of the ones I've created are fairly optimized to render quicker. But in this case, I did choose a few that have some very fine details and, well, will take a little bit longer. And of course, the more cloud layers you have, the longer it will also take to render. I also want to note that if you need a little more control separating some of the cloud layers in post, one option you do have is to modify each of the cloud layers' color. If we did want to be able to pull out specific layers, we could easily change the color of each cloud layer. And I'm just going to do red, green, and blue. And that way we will really be able to see that a little bit better. So if you wanted to have a color-based layer separation, and this will still work as a ZDepth when converted over to grayscale, at least for the most part. You might need to do a little bit of editing, but this way you can also separate cloud layers and kind of create a colored mask. This also allows you to generate a mask and a universal mask for all layers at the same time. That's pretty helpful. In this case, we have a combo of ZDepth and cloud mask based on the color. And even though a lot of the more distant clouds are darker, you'd be able to pull that color out pretty easily in post. And if not, really crank up the render or the power of the light. The only problem with that is you might run into some color blends and some different color changes. It might help to use an absolute color amount. In other words, if we wanted a pure blue, the RGB value would be 00255. And then if we wanted just red, it'd be 25500. So we could just continue to do that for each of the colors if you wanted something along those lines. But if you take a look at some of these clouds that are rendering, we have some yellow in the green, and whether or not that's a blend between the different layers, I don't really think it is. It's probably just because of the fall off of the point light, since we are maxing it out so much. It'll also tend to really overlight the lower and smaller opaque areas. Basically, the edge transparency might be too overlit in this case. But it is a nice way that you can separate the layers. And we can see too, on top we have purple for where the red is showing up. If I turn this down a little more, I also want to note that negative lighting does work on clouds. Now we don't have really a scene set up for that, but you can darken clouds by using negative values. Just to show you that really quick, because it is kind of cool. I figure I'll just add a little more. We'll go ahead and just add a point light just in front of the camera so we can see it. And I'm going to set this to a negative power. We'll do 500, see if that's enough. Oh, we do need to influence the spectral clouds. Make sure we turn that on. And we start to see a darkened area. 5000 will almost completely remove the current amount, since that is also the intensity of the primary light. But as I start to move this in closer, you're going to see it subtract from the lighting of the clouds. This also enables the decay color if you're working with a regular spectral atmosphere rendering. But if you take a look, now you can see we've basically cut a hole in the cloud, and that would work as a mask. So that's kind of of an easy way to create that sort of an effect just with the negative lighting. That also does work with metaclouds. And modifying the color of the negative light will subtract in different ways. Right on top, we could set this to, well, let's do a green and see what happens. And in this case, it ends up almost disappearing. Maybe it's not light enough. So you can really do a lot of modifications that way. Lots of little neat tricks you can do with negative lights. All different kinds of negative lights. Doesn't have to be a point light. It could be a spotlight. Lots of neat things you could do.